Okay, hi everyone, welcome back to this video series on the Comptia Security Plus course. Remote desktop services. Remote desktop services enables the remote control of Windows computers, most importantly for this section, Windows servers from a client computer. This client computer could also be on the LAN or out on the internet, so the term remote is used loosely. It can also be used to enable client access to specific applications. In Windows Server 2008, it is configured within Remote Desktop Management Server, and in Windows Server 2012 or 2 and higher, it is configured via the Remote Desktop Services server role. This application is in charge of authenticating remote users and will do so if the user has been configured properly. For example, users in question must have remote access permissions enabled within the properties of the account. Remote desktop services authentication integrates directly with standard Windows Server authentication. The remote desktop will have inbound port 3389 open to accept connections from remote clients. Client sessions are stored at the Windows Server running remote desktop services, which allows for disconnections and later reuse. Some of the vulnerabilities to remote desktop services and the remote desktop protocol in general, otherwise known as RDP, include an extremely well-known port, comparatively weak encryption, and lack of multi-factor authentication. Because of this, you might choose to utilize another remote control application. At this point, security is relative, and your decision on what tool to use will be based on the type of data you are protecting. As mentioned, the port is 3389 by default and is extremely well known, but it can be modified within the inbound computers registry at the following path: H key, local machine, system current control set, control terminal server, win stations, RDP, TCP. Third-party applications such as VNC, TeamViewer and so on can be more secure in this respect because they use web-based connections via HTTPS on port 443 out of the box. RDP is generally limited to SSL TLS 1.0 with a 128-bit key based on the RC4 algorithm, which is considered crackable, though difficult to do so. However, RDP can also comply with Federal Information Processing Standard FIPS 140 encryption methods, but additional hardware and software modules are required, which might incur an unacceptable expense. On the other hand, third-party remote control applications such as the ones mentioned earlier will often use RSA encryption for the HTTPS connection and the Advanced Encryption Standard AES, with up to 256-bit keys for session security. Some third-party applications also offer multi-factor authentication, for example, a passcode in combination with the standard username password login. However, multi-factor authentication could always be added to RDP as a separate module at a price. Your final decision of what application to use will be based on cost, the number of remote connections required, the platforms you need to support, and of course the level of security you desire. Remote authentication technologies. Even more important than authenticating local users is authenticating remote users. The chances of illegitimate connections increase when you allow remote users to connect to your network. Examples of remote authentication technologies include RAS, VPN, Radius, TACACS Plus, and CHAP. Remote Access Service. Remote Access Service, RAS, began as a service that enabled dial-up connections from remote clients. Nowadays, more and more remote connections are made with high-speed internet internet technologies such as cable, internet, DSL and fibre optic connections, but we can't discount the dial-up connection. It is used in certain areas where other internet connections are not available, and it is still used as a fail-safe in many network operation centres and server rooms to take control of networking equipment. One of the best things you can do is to secure a RES server is to deny access to individuals who don't require it, even if the user or user group is set to not configured. It is wise to specifically deny them access. Allow access to only those users who need it and monitor on a daily basis the logs that list who connected. If there are any unknowns, investigate immediately. Be sure to update the permissions list open in the case that a remote user is terminated or otherwise leaves the organization. The next most important security precaution is to set up RES authentication. One secure way is to use Challenge Handshake Authentication Protocol (CHAP), which is an authentication scheme used by the point-to-point protocol PPP, which in turn is the standard for dial-up connections. It uses the challenge response mechanism with one-way encryption. Due to this, it is not capable of mutual authentication in the way that Kerberos is. For example, CHAP uses DES and MD5 encryption types. Microsoft developed its own version of CHAP known as MS CHAP. An example of this is shown in figure 10.5. The figure shows the advanced security settings dialog box of a dial-up connection. Notice that this particular configuration shows the encryption is required and that the only protocol allowed is MS CHAP v2. It is important to use version 2 of MS CHAP because it provides for mutual authentication between the client and the authenticator. Of course, the RES server has to be configured to accept MS CHAP connections as well. You also have the option to enable EAP for the dial-up connection. Other RES authentication protocols include SPAP, which is of lesser security, and PAP, which sends usernames and passwords in clear text, obviously insecure and to be avoided. So you can see here MS CHAP enabled on a dial-up connection. The CHAP authentication scheme consists of several types. It authenticates a user or a network host to entities such as internet access providers. CHAP periodically verifies the identity of the client by using a three-way handshake. The verification is based on a shared secret. After the link has been established, the authenticator sends a challenge message to the peer. The encrypted results are compared, and finally the client is either authorized or denied access. The actual data transmitted in these RES connections is encrypted as well. By default, Microsoft RES connections are encrypted by the RSA-RC4 algorithm. Now you might say, who cares about dial-up connections? Well, there are two reasons that they are important. First, the supporting protocols, authentication types and encryption types are used in other technologies. This is the basis for these systems. Second, as I mentioned before, some organizations still use the dial-up connection for remote users or for administrative purposes. And hey, don't downplay the dial-up connection. Old school dial-up guys used to tweak the connection to the point where it was as fast as some DSL versions and as reliable. So there are going to be diehards out there as well. Plus, there are some areas of the United States and the rest of the world that have no other option than dial-up. However, RES now has morphed into something that goes beyond just dial-up. VPN connections that use dial-up, cable internet, DSL, and so on are all considered remote access. Virtual private networks. A virtual private network, VPN, is a connection between two or more computers computers or devices not on the same private network. Generally, VPNs use the internet to connect one host to another. It is desirable that only proper users and data sessions make their way to a VPN device. Because of this, data encapsulation and encryption are used. A tunnel is created through any LANs and WANs that might intervene. This tunnel connects the two VPN devices together. Every time a new session is initiated, a new tunnel is created, which makes the connection secure. PP2P and L2TP are common VPN connections that can cause a lot of havoc if the security settings are not configured properly on the client side and the server side. This can cause errors. You can find a link to the list of these error codes in the View Recommended Resources document online. Figure 10.6 shows an illustration of a VPN. Note that the VPN server is on the side of the cloud and the VPN client is on the other side. It should also be known that the VPN client will have a standard IP address to connect to its own LAN. However, it will receive a second IP address from the VPN server or a DHCP device. This second IP address works inside the original IP address, so the client computer will have two IP addresses. In essence, the VPN address is encapsulated within the logical IP address. As previously mentioned, dial-up authentication protocols such as CHAP are also used in other technologies. This is one of those examples. VPN adapters, regardless of the internet connection used, can use MS CHAP as shown in figure 10.6 to further increase authentication security. A separate radius server can be used with the VPN server. We talk more about radius in the next section. Figure 10.6 illustrates a single computer connecting to a VPN server at the office, which is typical and is known as a VPN remote access. However, organizations sometimes need to connect multiple offices to each other. This is done with a site-to-site configuration where each site has a VPN device, SOHO, router connector, concentrator or server that takes care of VPN connections for each network of computers. Site-to-site VPNs are generally more secure because an admin can specify that only specific networks can connect and can do it in a private intranet fashion. If a company is growing, site-to-site is the way to go. Whether the company is flourishing geographically or is simply inhabiting a separate space of the same building. When separate networks are connected in the same building, it is often wise to use a VPN because the physical wiring might pass through a public area. A Microsoft VPN can set up a standard Windows server by configuring routing and remote access service RRAS. Remote access policies can be created from here that permit or deny access to groups of users for dial-in or VPN connections. In a typical Windows server, you would need to set up RRAS as part of the network policy and access services role. Then you would right-click the remote access logging and policies node and access the network policy server NPS window to create a new RRAS policy. Figure 10.7 displays the initiation of the RRAS VPN policy. You don't have to use a server for incoming VPN sessions. Hardware appliances are offered by several vendors. Larger organizations that need hundreds of simultaneous connections should opt for a VPN concentrator as their solution, or it might be part of your unified threat management UTM solution. Older VPNs use either PPTP port 1723 or LT2P port 1701 with IPsec. They can also incorporate CHAP on the client side and radius servers for authentication. Newer VPNs protect traffic by using SSL or TLS. For example, OpenVPN uses this type of encryption. HTTPS openvpn.net SSL TLS solutions for VPN improve on endpoint security and enable always on VPN functionality where a user can always have access via the VPN without the need to periodically disconnect and reconnect. Watch out for split tunneling. This is when a client system, for example a mobile device, can access a public network and a LAN at the same time using one or more connections. For public network and a LAN at the same time using one or more network connections. For example, a remote user might connect to the internet through a hotel's Wi-Fi network. If the user needs to access resources on the company LAN, the VPN software will take control. But if the user needs to connect to websites on the internet, the hotel's gate will provide those sessions. While this can provide for bandwidth conservation and increased efficiency, it can also bypass upper layer security in place within the company infrastructure. While it is common, split tunneling should be tested thoroughly before being allowed by administrators. For example, simulate the split tunnel from a remote location, then perform vulnerability scans and capture packets, analyze the session in depth and log your findings. Cisco systems use the generic routing encapsulation GRE protocol to encapsulate a lot of different data, namely routing information that passes between VPN-enabled connected networks that use TP or IPsec. GRE might also make use of multi-protocol label switching, MPLS, and packet forwarding technology that uses labels to make data forwarding decisions. With MPLS, the layer 3 header analysis is done just once when the packet enters the MPLS domain. Label inspection drives subsequent packet forwarding. It is a natural evolution for networks that provide predictable IP services. There is a minor amount of risk when using MPLS due to its open-ended nature and when connecting from MPLS to non-MPLS networks. To mitigate this, the MPLS over GRE feature provides a mechanism for tunneling MPLS packets over a non-MPLS network. This feature utilizes MPLS over generic routing encapsulation, MPLS or GRE, to encapsulate MPLS packets inside IP tunnels. The encapsulation of MPLS packets inside the IP tunnel creates a virtual point-to-point link across non-MPLS networks. Radius versus TACACS. We mentioned radius previously in this chapter and in chapter 9 and said that it could be used in combination with a SOHO router in order to provide strong authentication. Let's define it further. The remote authentication dial-in user service Radius provides centralized administration for dial-up. VPN and wireless authentication can be used with EAP and 802.1x. To set this up on a Windows server, the Internet Authentication service must be loaded. It is usually set up on a separate physical server. Radius is a client-server protocol that runs on the application layer of the OSI model. Radius works within the AAA concept. It is used to authenticate users, authorize them to services, and account for the usage of those services. Radius checks whether the correct authentication scheme, such as CHAP or EAP, is used when clients attempt to connect. It commonly uses port 1812 for authentication messages and port 1813 for accounting messages, both of which use UDP as the transport mechanism. In some proprietary cases, it uses ports 1645 and 1646 for these messages. Another concept you will encounter is that of Radius Federation. This is when an organization has multiple Radius servers, possibly on different networks, that need to communicate with each other in a safe way. It is accomplished by creating trust relationships and developing a core to manage those relationships as well as the routing of authentication requests. It is often implemented in conjunction with 802.1x. This federated network authentication could also span between multiple organizations. Moving on, the Terminal Access Controllers Access Control System TACACS is one of the most confusing sounding acronyms ever. Now that we have reached the pinnacle of computer acronyms, let's really discuss what it is. TACACS is another remote authentication protocol that was used more often in Unix networks. In Unix, the TACACS service is known as the TACACS daemon. The newer and more commonly used implementation of TACACS is called Terminal Access Controller Access Control System Plus, TACACS Plus. It is not backward compatible with TACACS. TACACS Plus and its predecessor TACACS were developed by Cisco. TACACS Plus uses inbound port 49 like its forerunners. However, it uses TCP as a transport mechanism instead of UDP. Let's clarify. The older TACACS and ex-TACACS technologies are not commonly seen anymore. The two common protocols for remote authentication used today are Radius and TACACS Plus. There are a few differences between Radius and TACACS, whereas Radius uses UDP as its transport layer protocol. TACACS Plus uses TCP as its transport layer protocol, which is usually seen as a more reliable transport protocol, though each will have its own unique set of advantages. Also, Radius combines the authentication and authorization functions when dealing with users. However, TACACS Plus separates these two functions into two separate operations that introduce another layer of security. It also operates the accounting portion of AAA in its own operation. Radius encrypts only the password in the access request packet from the client to the server. The remainder of the packet is unencrypted. Other information, such as the username, can be easily captured without the need for decryption by a third party. However, TACACS Plus encrypts the entire body of the access request packet, so effectively TACACS Plus encrypts entire client-server dialogues, whereas Radius does not. Finally, TACACS Plus provides for more types of authentication requests than Radius. So here we go. Table 10.1, Summary of Authentication Technologies. 802.1x, an IEEE standard that defines port-based network access control. PNAC. 802.1x is a data link layer authentication technology used to connect devices to a LAN or WAN. Define EAP, LDAP, an application layer protocol used for accessing and modifying directory services data. It is part of the TCP IP suite originally used in WAN connections. It has morphed into a protocol commonly used by services such as Active Directory. Kerberos, an authentication protocol designed at MIT that enables computers to provide their identity to each other in a secure manner. It is used most often in a client-server environment. The client and the server both verify each other's identity. RAS, a service that enables dial-up and various types of VPN connections from remote clients. CHAP, an authentication scheme used by the point-to-point protocol PPP. That is the standard for dial-up connections. It utilizes a challenge response mechanism with one-way encryption. Derivatives include MSCHAP and MSCHAP v2. Radius, used to provide centralized administration for dial-up, VPN and wireless authentication. It can be used with EAP, and 802.1x uses ports 1812 and 1813 or 1645 and 1646 over a UDP transport. TACACS Plus, remote authentication developed by Cisco, similar to Radius but separates authentication and authorization into two separate processes. Uses port 49 over a TCP transport. Chapter summary. Users must constantly prove themselves in the world of technology. It's amazing how many times a person can be authenticated during a typical day. An example method could be using an authentication method could be as simple as typing an email address and password, for example, when logging into web-based email system, or it could be as complex as multi-factor authentication system, where a user is required to enter a password, then a PIN, then swipe a smart card, and finally scan a thumb. The complexity of the authentication system will be based on the confidentiality level of an organization's data and resources. If a person can supply the necessary identification and credentials, and finally authorize access data or enter a server room, or whatever the case may be, the authentication system can include methods such as something the user knows, something the user has, something the user does, something the user is, and somewhere the user is. These systems span from the physical door access systems and biometrics to the logical, localized and remote authentication software hardware. In some cases, to make things easier for the end user, an SSO is utilized where the user need only remember one password. Sometimes it's not even the user who is authenticated, but the computer itself. For example, when a network adapter adheres to the 802.1x protocol, authentication systems can fail. For example, in biometric systems, the most common failures are false acceptance, when a system authenticates a user who should not be allowed access to the system, and false rejection, when a system denies a user who should be allowed access to the system. A system has too many failures will cause user distress and should be reconfigured and tested carefully. One of the best metrics to analyze this failure rate is the crossover error rate, CER, which compares the false acceptance rate, FAR, to the false rejection rate, FRR. Examples of localized authentications include 802.1x, LDAP, Kerberos, and RDP. Examples of remote authentication systems include RAS, VPN, and Radius. However, there is a grey area. Some local systems can be used for remote access and vice versa. Remember, this is not cut and dry technology in general. For example, RDP could be used locally over the internet. It all hinges on what your organization needs for its end users. Nowadays, more and more people work from home or on the road, making remote authentication vital to the organization's efficiency and overall production. One thing to keep in mind is that attackers and con artists are very smart. In fact, the sad truth is that they are sometimes smarter than IT people. A poorly designed authentication system is tantamount to leaving the physical key in the door. However, a well-planned authentication system can save an organization millions of dollars and untold man hours in the long run. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.